It's Thursday, is that right? I think it's Wednesday. Oh, yeah. Normally it's just Tuesdays or Thursdays. That's fine, yeah. Yep, it is. So it's Wednesday, so that's my class time on Wednesday because we don't meet on Wednesday. This is Wednesday. All right, so what we covered since the previous exam, although you still need to know the neural net stuff because it's fundamental for the class. We studied a bunch of control architectures. We try the existing. Inverse control. Neural modeling. Pseudo inverse, where we didn't invert all the inputs and the outputs, we just inverted the reference and the state. And then we did the dynamic inverse. And we had different examples of this, and I'll list the different papers that we had, and we'll talk through what I put in like this. But the intent here is that I may give you a system and ask you to do copy existing, for example. Or give you a system and define the inputs and outputs and say do inverse control. Tell me how you do neural net inverse control. So that's the kind of question I have about these different architectures. So does that make sense? And we had a problem similar to that on the previous exam where we're given the system. I said I think it was do copy existing. Right? Yeah. And then we had a bunch of applications. And for these, I want you to know basically 3 things about neural nets for each of these applications that we're talking about. So we had aircraft, linear and touchdown. The distillation column. Truck packer upper. The adaptive flow control. That was with the MEMS, this smart ball thing. The bioreactor. The 2-tank liquid level control. And then we had the dynamic inverse aircraft. And so what I would expect you to do if I said, okay, talk to me about the distillation problem, I would want you to tell me what control architecture was used. In other words, which one of these over here was used for the distillation problem. How it was trained. And the architecture talks about the training method, but this is how training data is collected. And then the third question is essentially why a neural net? Why use neural net control for that particular application? And I should have answered all of those questions as we presented each one in class. The papers are all online as well. On so you can look at it. But you should have, hopefully, in your notes what we said about each one of these when we did that application. Why did we show you that application? All right, so that's kind of the control side. We also did system modeling. So I guess that's, if we're talking about the big things in the outlines, this would have been probably wrong number 1, that would have been 2, and then 3 is system modeling. And so a very fair game question here would be to give you a system and ask you how would you model it in the neural net. And this under this is if we had differential equations, right? We did a homework on how do you difference the differential equations and design the neural net model, what are the inputs and the outputs, or it may be just simply as basic as I described the system. That is, what are the states and the inputs, and you describe how you would do a model, how you would train. Like, for example, we did that with the track factor algorithm. We talked about what the model was and how the model was trained. So that's the control and system modeling. And then we did the competitive net stuff. So this would be Roman numeral number 4. And these were, well, this one has something that's competitive. Yes. And under that, we did the max net, Mexican hat, the Cahonen, self-organizing map, and then the learning vector quantization. So go back and review. We did a homework on all of that stuff, so make sure you remember how to do that. I won't expect you to memorize difficult equations, but you'll have to know the process to be able to apply it. And we've done this fairly recently, so this should be pretty fresh. And in fact, we've looked at a lot of these applications pretty recently, so it should be pretty fresh. And then we did the reinforcement learning. So be able to, I'll give you the formulas obviously because these are hard, but know how to calculate the V function. If I give you sort of like a grid world kind of thing, know how to calculate the Q and how to do Q learning. And my plan is to get that homework graded before the final so that you get feedback on that. So that's the second half of the semester pretty much. It's been a good semester. And that you've learned something about how to use neural nets for stuff. If you get a job somewhere and you end up doing something cool, grab it. Here we go. If you get a job somewhere and you end up doing a cool neural net application, let me know about it. Any questions? Comments?
What would be like an application where you use the max net? Would that pretty much only be used to find the big number? Or would it be?
Yeah, that's more of a kind of a toy problem that just introduces the idea of a recurrent network and a competitive network.
Okay.
Right, because we had those competitive, excitatory, and inhibitory connections, so it shows you how those work in the recurrent nets.
Okay.
Yeah, I don't know. There may be an application down the road. I haven't seen anything really useful with it, but it's an interesting idea. It shows you how the dynamics of that network works.